Hello everyone, welcome back. So in this video we will continue solution of activity questions. So in this video we will solve activity 7.6. So the first question here is uh, this exercise will be for central limit theorem. So the question is the average life of a coffee machine is 5 years. So we have given mu equals to 5 and the standard deviation is also given, which is 1 year. Assuming that the lives of these machines follow approximately normal distribution, find the probability that the mean life of a random sample of 16 such machines. So mean life of a random sample of 16 such machines. So we have a sample x1, x2 to x16 such machines, and what are those such machines? Those machines which follow random normal distribution, right? Each machine is following normal distribution. So this each x1, each xi is a machine which is following a normal distribution with mean 5 and standard deviation 1. So we have this situation, and then we have to find the probability that the mean life of a random sample of 16 such machines falls between. So we have mean life, which is x bar, because this mean life of 16 such machines we have to find. So it's a kind of a sample from the population, so it will be x bar, and it falls between 5.4 to 4.6. So that is what we have to find. And so to find this, what we have, so we know that each of xi is normal with 5,1, because the standard deviation is 1, then variance will also be 1. So now we need to find this thing. So this is probability that your x bar is less or equal 5.4 and greater or equal 4.6. So to apply central limit theorem here, what we want to do is we want to centralize this. We want to convert this x bar. This is a random, x bar is a random variable. We want to convert this into z, right? And where z is 1, z follows normal 0, 1. So that is what the central limit theorem wants to do. So to do that, what we want is we want to centralize this x bar. We want to standardize this, and the standardization will have, so it is, we will subtract the expected value of x bar from here and then divide it by standard deviation of x bar. So we know these values now. We are very much familiar with these values. The expectation of x bar will be equal to mu, which is 5, and then variance. So once we get the variance, we will get the standard deviation also. So the variance of x bar, we know that this is equals to sigma square by n. So in this case, it will be 1 by 16, right? And since variance is 1 by 16, standard deviation will also be 1 by, it will become the square root of this, which is 1 by 4. So we have all the information with us now. And now what we will do is we will standardize this. So what we do is we have this given equation, which is x bar less or equal 5.4 greater or equal 4.6. So the first step is we will subtract expectation of x bar, which is 5. So this subtraction will happen both sides, because our inequality expression should be balanced. So it is 5.4 minus 5. We'll subtract 5 from here. What we are trying to do is we are trying to go from x bar to this expression here, x bar minus expectation of x bar divided by standard deviation of x bar. So to go here, this is the extra things we are doing. We are subtracting some constant and then we are dividing by some value. So those things, those extra things we have to do here also, as well as this left hand side also. So it will be 4.6 minus 5. So we have to do it both sides. Then only our expression will be balanced. And now we will divide this whole thing by standard deviation of x bar, which is 1 by 4. So this should also be divided by 1 by 4, and this should also be divided by 1 by 4. So by doing this, what we will get is probability of Now this expression here, this has become z. So we have changed it to z, and that will be z less or equal, this will be 0.4 divided by 1 by 4 greater or equal. So here it will be minus 0.4 divided by 1 by 4. Right? And this expression here we can write as probability of, okay, so not probability of, uh, so we can write it in terms of CDF of z, which is fz of, so it is like fz of b minus fz of a, where this is my b and this is my a. So we can write as fz of 0.4 divided by 1 by 4 minus fz of minus 0.4 divided by 1 by 4. And we also know this property that fz of minus alpha can be written as 1 minus fz of alpha. So why this is true, you can go look at this. This really very simple. You can just simply find it from the plot of a normal distribution. Okay, so we can change it as fz of 0.4 by 1 by 4 minus, and we will write 1 minus fz of 0.4 by 1 by 4. And to solve this, we will get fz of 0.4 by 1 by 4, and that is minus 1 plus, again it will be, so I can write it in the same expression will come, so I can write 2 times fz of uh, this fz of 0.4 divided by 1 by 4 and then minus 1. So let's simplify it more, and what will be the value inside it is 0.4 divided by 0.25. So 0.4 divided by 0.25, it will come 1 by 6. So that is 1 by 6 times minus 1. And this 1 by 6, fz of 1 by 6 value is given, which is 0.94. So it will be 2 times 0.94 minus 1, and that will be 0.88. So 0.88 will be the answer of this question. Okay, so this is how you will apply central limit theorem. The idea is to just make the convert the random variable into standard normal random variable. So we'll solve one more question. I will clear this out. Okay, so now let's go to the next question. And this next question says that the random variable x representing the number of cherries in a cherry puff has the following probability distribution. So the probability distribution PMF of x is given, where x represents the number of cherries in a cherry puff. So it is representing the number of cherries. So that is kind of important to know, that this is number of cherries in a cherry puff. And so what is given is the distribution of x, which is given in the table, and find the probability that the average number of cherries in 64 cherry puffs will be less than 7. So there are 64 cherry puffs, so we can write it as x1, x2 to x64. So there are 64 cherry puffs are there, and each x1, x2, x4 is representing the number of cherries in those 64 cherry puffs. So, and what we want is, we want the total number of cherries which should be less than or equal to 7. We want to find the probability of this, that average number of cherries in this 64 cherry puffs puffs will be less than 7. So that is the average is x1 to x2 x64, and we divide this whole thing by 64, which is x bar, and we have to find the probability that this x bar is less than 7. So that is the probability we have to find. So again we will use central limit theorem here, and central limit theorem says that we can approximate this distribution to a normal 0, 1 distribution by doing simple subtraction and then division, which is x bar minus expectation of x bar. So whatever random variable we are trying to standardize. So here we are trying to standardize this x bar. We want to approximate the distribution of it with the normal 0, 1 distribution. So what we will do is same thing so we need to find expectation of x bar, which is same as expectation of x, and this expectation of x we can find from the table, which is 4 times 0.3 plus 6 times 0.1 plus 8 times 0.4 plus 10 times 0.2. So this value will be equal to 7. So now we have to find standard deviation of x bar. So let's first write it uh, in this way. So we need to find x bar less or equal 7, and now we will standardize our x bar. So it is x bar minus expectation of x bar, which is 7, less or equal, it will become 0. So even if we try to, we don't need to calculate standard deviation of x x bar, because here when you divide this thing it will again still be 0. So we don't need to find a standard deviation of x bar. So the same thing will become, now this thing has converted to z. So we'll write z less or equal 0. That is what we have to find. And that will become fz of 0. And we know that the fz of 0, so we need to find the value of fz of 0. So this value will be equal to 0.5. So in exactly same manner, you can solve question number 3 and 4 also. And you have to make sure that you first try to figure out what is the question that has been asked. For example, is it asking about the x bar here? Is it asking about the average or just the sum? So sometime it could ask just the sum. So here you can write it as y, which is equal to x1 plus x2 plus xn. And it can ask about this just this sum. And in this, when you centralize this y, you have to take the expectation of y and then divide by standard deviation of y. So expectation of y here won't be simply expectation of x, because it is because y is not the average or the sample mean here. So expectation of y will be n times expectation of x. So there are few things you have to remember. Be careful while calculating the expectation of y and then standard deviation of y. And apart from that, you can solve rest of the things. So question number 3 and 4 can be solved in the similar manner. Question number 5 is related to the previous exercise that we did, where we have to find the MGF. So it's a straightforward question. We have done the similar question in the previous exercise. So that can also be done after watching the previous videos. And the question number 6 is asking what is the sixth moment of the normal 0, 3. So we know that for the normal 0, sigma square, the MGF function is e power lambda square sigma square by 2. So we have seen this in lecture, and to get the, so in this, using this MGF function, how to get the uh, sixth moment. So that is what we are trying to solve. So one way is you can simply differentiate it 6 times and then put lambda equals to 0. So while after doing that, you can solve. So for example, you have to find the first moment. So you will differentiate it with respect to lambda, and then after that you put lambda equals to 0. So we know that the first moment is just the mean. So we should get 0 as our answer because 0 is the mean here. And to verify this, we can differentiate it. So when we differentiate it, it will be uh, e power lambda square sigma square by 2 into 2 times lambda sigma square by 2. And this will be cancelled out. And when you put lambda equals to 0, because this lambda is here and everything will become 0. So you can differentiate this expression 6 times and you will get the sixth moment. So by doing that, you will be able to get the answer for the sixth question. So thank you. This is the 7.6. So in the next video, we will discuss rest of the activity questions.